Welcome back. So we're continuing with our SAT videos. Again, I recommend attempting the problem, pausing the videos, and then watching the solutions to try to um, fix what you might have messed up with the first time through. So give this problem a shot. All right, we're looking at this, and I see decagrams, which we don't often see listed out there. We usually skip from grams all the way up usually to kilograms. We don't usually talk about deca or hectograms, or decigrams for that matter. And we also have milligrams to grams. So a hospital stores one type of medicine in 2 decagram containers. Based on the information given in the box above, how many 1 milligram doses are there in one 2 decagram container? So basically I want to get everything in terms of the same measurement, and it's usually easiest to get them in terms of the smallest measurement. So from here, since 1 decagram is 10 grams, that means that 2 decagrams will be 20 grams. Okay. Now I can sort of use the same process to say, okay, if 1 gram, so let me turn this around so we see it the same way. 1 gram is 1,000 milligrams. That means that 20 grams will be 20,000 milligrams. And from all of this, if I want 1 milligram doses, then I can see that I would have 20,000 of them. Now that's how I would do it. If you're having a little bit of trouble working through this, it seems to make sense when I'm saying it, but it might not make sense when you're doing it. You could always do one of a couple of things. So you could use, what's that called? I don't remember the term for it, but basically not dimensional analysis, maybe stoichiometry would be the term for it, where I know I'm starting off with 2 decagrams, and I want to get something at the end that is in milligrams. I notice that I can go from decagrams to grams. Let me change colors there so you see what I'm doing. So I'm going to use this one to go from decagrams to grams. To cancel out decagrams, I can put it in the denominator. So decagrams down here. I want to go to grams, so I'll put grams up there, and I'll use this number with grams, that number with decagrams, because 10 grams is the same thing as 1 decagram. This is not changing what I have, it's basically multiplying by 1. After that, I will get to grams. I want milligrams, and now notice I have an equation that can allow me to convert those. I have grams at the top. To cancel that out, I put grams at the bottom. I'll go to milligrams at the top, and I'll take this number and this number with milligrams and grams respectively. So 1,000 up here, 1 down there, and when I multiply 2 times 10 times 1,000, I get 20,000. And when I multiply the 1, let me make sure I cancel those out for you guys. The grams are gone. By 1, it's over 1, which doesn't change anything. And notice my units I have left are milligrams. There's another way, if that doesn't make sense. I'm not going to go all the way through this because it's kind of needlessly time-consuming. But if you're having trouble seeing this or seeing this, you could always use proportions. So I know that I have 2 decagrams. I want to know, I'll do it separately. I want to know how many grams that is. So that's going to be x grams. I have this equivalent, or this equation between decagrams and grams. So I know 1 decagram is 10 grams. And I can cross multiply. I get 20 equals 1x. So I know I have 20 grams, and then I'll put a little ellipsis, dot, dot, dot. I'll do this again. Okay. Next problem. Give this a shot. Okay, so I have this nice little bar graph that is giving me rooftop solar panel installations in 5 cities. And it's always worth looking at what you have carefully. So this is my cities, city A, B, C, D, E. This is my probably number of panels. I'll read it over here. Be careful. See, we're counting by. Make sure we're not counting by different numbers than you think. The number of rooftops with solar panel installations in 5 cities is shown below. In the graph to the side, if the total number of installations is 27,500, what is an appropriate label for the vertical axis in the graph? Okay, so here's the idea. I need to figure out what these numbers mean. Is this one roof, which I thought it might have been the first case, but apparently that's not going to get me to this number. Is this 100 roofs? Is this 1,000? Is this a million? So we have to figure that out. So we know it's the number of installations. And I'll do it this way first. I'll show you a better way in a sec. So basically, if I just take these bars as I have them, I have 9, I have 5, I have 6, I have 4, and I have what looks to be 3.5, close enough to 3.5 for me. And I could do this in my head. I could do this with a calculator. This is a calculator test. 9 plus 5 is 14, plus 6 is 20, 24, 27.5. So this gave me a total of 27.5. I want 27.5 thousand, so that's what I get there. Because if this is 9,000, if this is 5,000, all the way up to this being 3,500, that will get me 27,500. Now, a slightly better way that doesn't do this, I mean, this addition here is kind of junk because I don't know what the units are. I could say, I'm not sure what this is, but let's treat this as 9x. Let's treat this as 5x. Let's treat this as 6x, because I don't know what these units are. So we have plus 4x plus 3.5x. And I know that I want this all to add up to 27,500. And when I do that, I get 27.5x is 27,500. And again, it is a calculator test, so I can do, if I can't do it in my head, 27,500 divided by 27.5, and I see that, okay, each of these x's, each 1x is 1,000 roofs. So that's where I get the number of installation in thousands. All right, give this a shot. Okay, so here we have an absolute value, I guess it'll be an equation. So it says, for what value of n is the absolute value of n minus 1 plus 1 equal to 0? So first off, what I know, so absolute value of this must be positive. Okay? If I take a positive number, I guess at least not necessarily positive, but non-negative. It could be 0. If I take something that is 0 or bigger and add 1, that lets me know that absolute value of n minus 1 plus 1 has to be greater than or equal to 1. And there's nothing that's greater than or equal to 1 and equal to 0. So there is no such n. Now, other possibilities, just in case you started down something, you remembered something from maybe freshman or sophomore year in high school, and said, okay, this is an absolute value equation where we would have absolute value of n minus 1 plus 1 equals 0. And we get to the absolute value, we subtract 1 from both sides. We get to the absolute value of n minus 1 equals -1. Now, same issue here. You should notice that, okay, I can never have an absolute value be negative. But let's just assume that maybe you forgot that rule and just kept on soldiering on ahead. And if you remember, when you're solving absolute value equations, you get two possibilities. I would get either n minus 1 equals what we have here, or n minus 1 equals the opposite of what we have here. And when I solve this now, I get n equals 0 or n equals 2 by adding 1 to both sides. Now, I followed the steps that you probably learned in school. This is something called extraneous solutions because I know that if I check n equals 0, so at n equals 0, the absolute value of n minus 1 plus 1 would be 0 minus 1 plus 1. Absolute value of 0 minus 1 is 1. 1 plus 1 is 2. That's not equal to the 0 that we want, so I know that this is not a solution. Similarly, when I put 2 in, I'll get the same thing. 2 will not be a solution. So if I do dive in and solve it, I won't get anything. A final way to look at this, I could actually look at this as a function. Let's consider the function y equals absolute value of n minus 1 plus 1. And I'm going to draw a graph of that. And if you've learned about absolute value equations or absolute value graphs, I know that this is a vertex at 1, 1. And it opens upward because I have a positive 1 coefficient here. And we're saying, when does this equal 0? Not when's x 0, when does it equal 0? So when does this hit this x-axis? And you can clearly see, never. All right, give this a shot. All right, so for the last two problems here, we have the same situation, and then we look at some separate questions. So questions 9 and 10 refer to the following information. We have A equals 1052 plus 1.08t. The speed of a sound wave in air depends on the air temperature. The formula above shows the relationship between A, and the speed of a sound wave in feet per second, and T, the air temperature in degrees Fahrenheit. Okay, which of the following expresses the air temperature in terms of the speed of a sound wave? So this is actually, it looks crazy. It's got a lot of context in it, kind of like a problem we saw in the no calculator form, but it's actually very simple. This basically says, hey, here's an equation. Which of the following expresses air temperature in terms of, so this says right here, let's take that equation and solve for T. So I have A equals 1052 plus 1.08T. To solve this for T, I notice that I have to get rid of the 1052 and I have to get rid of the 1.08. Because the 1052 is done to the entire side, add to the entire side, or farther away from the t, or however you look at this, I'll subtract 1052 from both sides first. Of course, a and 1052 are not like terms, so I will be left with a minus 1052 equals 1.08t. And now, to get rid of this multiplication, I'll divide by 1.08 on both sides. And I'll have t by itself, and I'll notice, let's find my answer. T equals a minus 1052 divided by 1.08. There we go. Check to make sure that nothing else works. All right. Give this a shot. Okay, so in this problem, we have the same equation, and now we are saying at which of the following air temperatures will the speed of sound wave be closest to 1,000 feet per second? And again, it looks crazy. We're talking about sound waves, speed, temperature, feet per second, things that make this kind of weird sounding, but it's actually a really easy problem to do. So I'm going to use my equation, A equals 1052 plus 1.08t. I'm going to realize that they give me the speed is 1,000 feet per second. And the speed, let me see, is A. So I'll put the 1,000 in for this A. And just solve for t, like any normal two-step equation. Subtract 1052 from both sides. Get negative 52 equals 1.08t. And divide by 1.08. Now I could try to guesstimate. I know this is going to be a little bit less than, or a little bit more than negative 52, but it's a calculator problem. Let me grab that calculator and so clear this off. We have negative 52. I don't know if it's going to do that correctly. Divided by 1.08. There we go. So negative 48.15-ish. The closest one here is negative 48 degrees Fahrenheit. Now, one other thing that could be really, really nice for you on here. Let me change colors. If I recall, I just solved an equation for t, and here's why I did it. If I have this equation right here, I can just put my a value in and get my answer. So let me rewrite this equation on the next slide and show you what I mean. So we knew that t would equal a minus 1052 over 1.08. All I need to do is, if I know this, I can just put my 1000 here. Now I have a function of t on the variable a, and I'll get 1000 minus 1052 over 1.08. I type it in and press enter, and hey, same answer. All right, hope that helped out.